Okay. I think we're good.
Okay.
Yes. Now we can see you correctly too.
Great.
Great.
Huh?
That one. The front screen is blurred.
j'arrête et je relance.
Yeah. Did the camera went off? So I'm not seeing them. Anyway, let's just get started. So thank you everyone for joining. This is the Center for Science and Technology Innovation. We're here with our partners, and today we're going to start day 1 of 3 2-hour sessions in which we are going to present to you ways in which, as a scientific and design community, we believe there are some ample pathways for achieving net zero. And there's a lot of discussion about net zero. What we want to do is begin to delve a little bit into the technical aspects of what it would take to achieve net zero without overburdening everybody with technical details. So we'll switch back and forth. We have the first presenter will be Professor Wandiga, who is managing trustee of CSTI and one of the first climate scientists across Africa. He will contextualize the information not only for today, but also for the sessions to come. Then he will be followed by Dr. Elena Rosca at Ashesi University in Ghana. We'll learn a lot about the sensors that we need to collect these data. Right now, a lot of people are using software to estimate emissions. That could be erroneous and dangerous, especially if the software model is not developed using parameters for our local climates. And so we want to be able to show how that can improve. And Dr. Elena will take us through some of that, their experiences in building these sensors locally. And then she will be followed by architect Cedric Sambang from Cameroon, who will start guiding us through how we can take our local materials and work them as high performance construction materials so that we're not held in this paradigm of always having to import. We have plenty of quality for good materials and also sustainable design that is indigenous in our different traditions. So with that, I will ask my Professor Wandiga to switch seats with me because we're having a little bit of a difficulty with the group camera. Hold on 1 second.
Good afternoon, everybody. Maybe morning,
afternoon.
evening, or good night. But I want to talk about regenerative construction. Africa is the leading continent with mega projects, regenerative projects. For instance, the pyramids of Egypt have been with us for over 400 years, 4,000 years, I beg your pardon. And they are still with us. They have left a legend in our thinking. We have also the stone walls. We have one in Kenya called Thimlich Ohinga, and we have the Zimbabwe Great Walls. These are walls which were built without any cement. And certainly they have left a legend and they are still with us. And for that reason, I'm asking, is Africa going to have a legendary stone wall again? Stone wall or a pyramid or any other construction which will stay with us? Let me let me go ahead and look at the building of African construction nature spheres. The nature spheres we are to build have been very difficult for us because we always lived with nature, and therefore we did not conceptualize that we will have to build it. We thought we always had it, but now we have to look at the way we are developing. We are increasing in having slum areas or areas where we have problems like cities. The rurals are being changed. And some of the examples which we can look at are the earth buildings that we can see. For instance, the pyramids were built by stones and there was no binding. Now, if you were to take granites and put them together, we have to find a binder. And finding a binder for granites is going to be difficult. But we have in the past the Timbuktu Jena village, which was built by earthworms. And we have that one is still a living example of earthworms that we can do. And we can easily continue to look for such earthworks which would survive our area and give us prosperity in our society. When you look at building an African construction in our areas, we often construction nature sphere. We often think of having heavily industrialized countries patterns. We copy those patterns, but we don't have the feasibility and the possibility of getting those patterns. Emerging industries like ours have to create new patterns and have the pleasure of reducing the emission of greenhouse gases in those patterns that we create. I'm particularly interested in seeing that the smoke which is emitted, the CO2 that is emitted by industrial countries, become less and less so in the developing countries, and particularly in Africa. And I say this because, first of all, our consumption of oil and other things is only about 4 or 5%, and we should be emitting only about 4% of the greenhouse gases. But we are not doing so deliberately so that we can emit less greenhouse gases as we go along. And this is going to create us a problem. And the reduction of greenhouse gases is one of the cornerstones of the climate change. Why greenhouse gases? I want to bring to your attention that there are a few of them, but the one which is used most often is the carbon dioxide, which forms about 0.1% of, or 1% of the atmosphere. What is happening with carbon dioxide is that it becomes a heat sink. It stays in the environment, in the atmosphere, and absorbs heat in the long-range energy level way, but emits that same heat in the short wave, the long wave, and emits it in the short wave. Now, absorb the short wave and emits in the long wave, beg your pardon. And if you think that the long wave is useless, most of you have used your cooking microwaves, and you see how fast the microwave cooks. And that's how the earth is being baked, because the heat goes up and is sent down again, and then sent up and sent down. And so we have an exchange, continuous exchange of heat going up to the atmosphere and being radiated back to the ground. We have the advantage here because we have the advantage that our financial demand is not as high as the financial demand of the industrial countries to build. For instance, the industrial countries require at least $150 million plus to build a complex or a nature sphere. For us, we need about something like $20 million to build a nature sphere. And we needed many 20 millions, not one block big 150 million. And that gives us the advantage that in the developing countries, we can replicate and do a lot more and create more nature spheres with the money that we get. And for that, we need building projects, we need pooling information, and we need to see how we can work with one another to do those two. Lastly, let me say that building an African construction nature science will greatly help us industrialize much faster, and will give us a space which is livable, which is enjoyable, and we need to see how we can begin to gather data that will enable us to do all of those so that we have more nature spheres in our environment. Lastly, we need models. We need models, not copy models from the developed countries. We need to develop our own nature solutions based on nature-based solutions integration. And building these models require most of us to change our mindset and to begin thinking the way our forefathers thought, that they had forever a beautiful nature living environment. Thank you.
Thank you. I'm in the background. I'm going to, so we're having trouble with the chat function. Anybody have questions? You can raise your hand and then I can promote you to allow you to talk, to ask Professor any questions. See, we have about 7 people in the chat. So if you have a question, you can raise your hand.
Excellent. I think you have all understood me. So let us save time.
Oh, here we go. There's Sebastian. Okay. Go ahead, Sebastian.
Hello, everybody. Thank you very much for taking the time to explain us the way forward. Let's say from where you are looking at, what do you see, let's say, as, I mean, you've been talking about financial challenges, but is there any other challenges you have in mind that prevent you to accelerate towards achieving your goals on a short-term basis?
I think financial challenges are always there, but when you have a good idea, you will find a financier. So always look for good ideas, be innovative in your ideas and approach it, and you'll find people coming to help you do the job. Alternatively, we can also persuade our governments with the good ideas to help us solve those good ideas. But I strongly believe that any good idea will be funded today.
And just to add on that, Sebastian, this is Cecilia. Data, but that is avoiding getting into that because both Elena and Cedric will present a little more on some of the data, and then I'll loop that back in. So when we're saying 20 million versus 150 million, in theory, a building costs what it costs, and some would say if you're importing materials, it would cost more in the African context, but that's what we're challenging. Why are we importing so much of these materials? So data to be able to balance and make those arguments from a scientific basis is also a challenge.
Thank you very much, both. Appreciate it. Thank you.
Any other questions?
Fine, thank you for listening.
And now we'll switch to Elena. You ready?
Yes, I am. Can you hear me?
Yes.
Great. I just need to share screen.
Let me stop sharing on my end. There.
And I'm gonna.
And for those in the audience, you can also be typing questions in your the Q&A box.
So I think you can see my screen now, correct?
Yes. Yes, we can.
Great. So thank you very much for this amazing opportunity to participate in this event. And I'm going to try to give you a little bit of just a peek on two projects. And one is more geared towards materials, and the other one is geared more towards sensors. And I'm hoping to leaving you with an idea of how perhaps we're looking into incorporating a little bit of both. So first of all, I wanted to start by acknowledging and thanking giving my thanks to the university and particularly to the students who've been working with me on these two particular projects. And to introduce a little bit perhaps about the Ashesi University, which is located in Ghana, and it's a small private university, one of the top universities currently in Ghana. And we have also, as a university, have made a big commitment of introducing students to the issues of climate change and really trying to really being intentional of convincing them to think and look at these options and these problems and come up with innovative solutions. So the first of the two projects is a project that actually builds or uses kind of a biosensor approach, but it's also the same approach can be used for creating new materials. And we have been really focused on the coastal environment. The coastal environment is a big problem globally, but coastal erosion, I should probably say correctly, has been a big problem globally, but also a very big problem in Ghana. We have seen communities entirely being swept to sea. And as you can see, it's been, a large percentage of population lives within proximity to the environment, to the coastal environment. Of course, the climate change is creating big problems, which led to increased erosion, to changes into patterns of hurricanes and typhoons and strength of those natural elements, which creates very big problems for these communities. And so typically our solution has been focused on creating some sort of defense against these forces of nature. And those those are typically these really large concrete walls which project into the ocean and try to protect and reduce the erosion that's being caused by the ocean. Unfortunately, there are two things that we observe with them. One is that they are really not they're creating problems for the ecosystem, and secondly, they're using loads of concrete to actually build these structures, and they're not really inducive of interactions with the natural ecosystem, and so it produces a lot of destruction. And so the group of students who decided to work on this problem undertook this project over the summer, and their focus was to develop a natural or a biologically solution to this problem and create a material that it will be a lot more friendly to the ecosystem. They presented their work at the Internationally Genetically Engineered Machine, which is a big international competition for these type of projects, and from all over the world, students come in and present. So just a little bit, I'm not going to bore you with all the detail, but just to give you a little bit of insight in their approach. They took inspiration from one microorganism, the Sporosarcina pasteuri, which is an organism that is able to break down urea into components, and by using of a urease enzyme. And then using calcium, it actually produces calcium carbonate, which can then precipitate and aggregate and form a brick material, similar to concrete material. The students also were interested in addressing another global problem, and also very prevalent in Ghana, in the plastic pollution, the ocean plastic pollution in particular. So they looked at another microorganism which is capable of adhering to the plastic particles and actually enzymatically breaking them down into its components, the ethylene glycol and the tetraphthalate. And so they took these genes and they put them into different bacteria, as a marine bacterium that is normally existing in the oceans. And they created a small micro ecosystem in which these bacteria are either producing these enzymes and are able to continue creating this material on continuously. However, because it's enzymatic process, the pH can go out of balance. So they've created organisms which are able to be turned on when the pH balance is lost, bringing back the normal pH that is needed for the production of these materials. So you might ask, how does this compare with a concrete that we normally use in construction, and how do we make them? So to make them, really, we mix the sand and the media and the cells. We allow the cells to grow. They lead to the formation of the calcium carbonate and its precipitation. And then the ethylene glycol, which is coming from the plastic, source sort of as a physical cross-linking of this formulation, giving rise to these bricks. There's, again, a bit of an issue there that we need to optimize as to how much how much humidity do we need to allow in these bricks for the maintenance of the organism, but also to be able to maintain the properties, the mechanical properties that are needed for these materials. And so you might ask or wonder, how does this compare to the current state of art, to the abiotic controls? And this is data not from our labs, but from the research that we took inspiration from, and that shows that the fracture of the living building material is actually similar, if not even a little bit higher than the abiotic control, that we can see that they were able to carry load, and it takes even a higher load to induce a crack. And they're able to also have similar stress and strain properties. Now, the additional thing which the abiotic controls are not able to do is that these materials are able to self-heal. So if these cracks occur and the micro cracks occurs, we have bacterium that are able to turn on when light becomes, they're under a light promoter or switch. Because as a crack happens, you are getting a higher penetration of light. So those bacteria will be activated, starting to produce even more calcium carbonate. So therefore, trying to bridge this crack. So this is kind of in a material production, and these bacteria, as we engineer them to produce a material, we can also use them we can engineer them to sense different environmental factors, such as metals, for instance, in the environment. We can use them also CO2 detectors. We can use them to create or clean environments as well. So there's loads of different applications for them. Now, for the next couple of minutes, I wanted to highlight a different project which looked at monitoring environments. And it was also in the context of climate change, looking at organic waste, which contributes to a lot to the greenhouse gases, and also to solve a problem of food waste, where we know about a third of the food production produced globally is being wasted. And so as a result of that, we looked at nature again, and we looked at particularly the black soldier flies, which are non-pathogenic, and they really don't transmit or transfer any disease, but they produce larvae that's extremely high in protein, which can then be used as a feed for poultry or for any other animals, particularly for fish as well, and actually has been even introduced for human consumption. But rearing of these flies, it's a little bit time consuming and difficult. And again, it's very sensitive at the environmental conditions. So these students have looked at developing this particular housing that is capable to monitor not only the growth and the environmental conditions that are necessary for the flies, but also the conditions that are necessary for the food waste that's being introduced, in terms of its aeration, in terms of humidity, temperature, and it's actually able to self-adjust to maintain an equilibrium environment, and then collect all the data. So those are sensors that collect data and then send it remotely to clouds, and then we can do a lot of analysis on looking at how to maintain, or what to learn about the system and how to maintain it and how to optimize it even better. We're using AI and machine learning to be able to make these predictions. So lastly, I would like to leave you with a little bit of an idea that we can combine some of these processes, and we can create materials that are enabling nature and working with nature to purify or maintain a good environment, that we can monitor environment in terms of, as we just heard, that's important to have data in terms of cooling information, in terms of heating information, what's the rate of cooling, how long does it will take for a particular material to cool, and then to maintain an environment that is clean and healthy for the inhabitants of that. So we're looking at collecting these data continuously, monitoring them, putting them on a cloud, and then using AI and machine learning algorithms to try to make predictions and be able to adjust these environments. So I hope that with this, I gave you a little bit of an insight on some of the projects that we do, and I hope that you would be willing to come with us on this journey of building with nature for a much better humanity. Thank you very much for your attention.
Thank you, Elena, and thank you for a wonderful overview. One of the main reasons we're bringing Elena and Cedrix into the presentation, whenever we are at meetings, and this happens to us particularly with private sector members who've had foreign experience, the first pushback we get is that all the advanced research is happening in Europe and the US and other places, and there's no such talent on the African continent. And we wanted to show live and well for those who, to show it's here. There's no need to go, and if companies are willing to go and spend $3 million US dollars to get a prototype done in a foreign lab, that 3 million could go a lot further by investing in Elena and her team and other teams. You'll get the same exact quality. You'll get people who actually understand what the local conditions are. They know the local microbes, they know the local performance data, so that when you're bringing it back in, you don't have to spend again to get your product recertified and readapted and adjusted to the local conditions, because it's already been done locally. You have a question here from Cedrix of in between panelists. Can your process help monitor local architecture, ancient design, or hybrid monitor? So, Elena, I think when you were mentioning the high-level sea rise, I know here we're having the same problem on our coast. And we are trying to estimate, like, for example, Fort Jesus, and there are a lot of UNESCO World Heritage sites. We're trying to monitor how to get those sites, the rate of deterioration of the materials, and how, yeah.
So I understand. I don't know. We haven't done anything like that. We can probably consider and looking. We just need to find what are the properties of deterioration that we're looking for, right? And what can we measure? So that can be done either electronically, or it can also be done biologically. For instance, if we're looking to monitor a particular breakdown molecules, for instance, we might be able to engineer something that's biological that can measure those.
and Dad will get into a little bit more of that tomorrow, but for example, when he was mentioning carbon dioxide, it's one of those gases that triggers oxidation when it reacts with different materials. Could we potentially, by having a sensor that detected the level of carbon dioxide near a building, be able to start estimating the level of the oxidation of the materials on the exterior of the building?
That's a very good, very intriguing question. And I would want to say that I think so, that I think it's possible. We haven't looked at it, but we can definitely consider that something that I'll put on my next projects to think about. I think it's a great point, a really, really great point. So we'll look into that.
Thank you. Any questions from the audience before, so that we don't turn this into a inter-panel discussion? Any questions from the audience? You can type in the webinar chat or raise your hand so that we can call on you. We're a little ahead of schedule, so try to give chances for. Let me ask a question to the audience. Thus far, what you've heard, and you're all coming in from different perspectives, be it the community or private sector. Do you see anything that you could use, or any information that you could carry forward from Elena's presentation to others? Yes, Cedric is saying happy because he needs more time for his presentation.
So there are two questions in the chat. That one of the questions for Charity says, are there similar IoT solution for wastewater? And the answer to that is yes. And we have been working on several different options for those. So yes, I can give more answers to, more examples of that. Not at this moment, but yes, we have been working with quite a bit on those. And then Charity also, a different Charity, it looks like, had asked, on the self-healing concrete on large-scale production, is it sustainable in Africa given the procedures and infrastructure needed, and what are the impacts of the bacteria? So I don't, I'm not the best person to answer in terms of scalable and, how would this be, scaled up. We haven't discussed with a lot of people to think about that. There have been examples in other places, particularly I believe in the States, that have used similar approaches. So I'm tempted to say that yes, this is scalable. The bacteria, particularly I think in Africa, carries a lot of bad reputation in a sense, because I think we've seen it being creating lots of havoc in terms of health related issues. But these particular bacteria are non-pathogenic. They are bacteria that exist in the environment. And the example with the sea defense walls, I'm not so sure that the bioconcretes are going to be very easily translatable to buildings, but they're definitely a good approach for the marine environment, because they actually need the water, the ocean through to be able to survive. So putting those at that interface between the land and the water, they are continuously exposed to water, maintaining them, giving them the viability that is needed. So I think for that application would be good. For other applications, we don't know that for sure as how to maintain the bacteria alive. There's also other approaches. Instead of using live bacteria, we can use bacteria that may create spores. And so those are not functional bacteria that can be incorporated in the concrete. And then when the fractures occur, the humidity that comes with that fraction revives the spores into growing bacteria, which can then use the same process of producing calcium carbonate and healing or closing that particular crack. So that's another approach that perhaps we could transform that into the current material that are not in direct contact with water, for instance.
And just to add on what Elena is saying, the applications I've seen in the US of self-healing concrete in buildings, water is the key thing. What they do is they put these sensors and they develop bacteria that get triggered not only when there's water, but when there's mold. So the self-healing part of the bacteria goes to work when it's triggered by a certain level of moisture and mold in the concrete structure. And when that disappears, the bacteria stops working. You have another question, I think, from Cedrix in terms of, do you build sensors?
So we have for instance, the examples that I showed you, these bacteria, and we do build them and test them in the lab and working on producing them in the lab. The electronic sensors we also produce. So the project that you have seen that I showed you with the black soldier fly was entirely built by a team of students. They built their own sensors, they integrated them, they interconnected them so they are IoT enabled and were able to collect data. So yes, we built them from scratch.
And that's an important part because we did we were doing water sensors, and the frustration that we had was even if we had the technicians, you had to import the parts. And until we have enough people producing, it tends to be cheaper to import parts. Now, what happens is, like, for example, you have the COVID-19, and what happened to us doing our pilot was global supply chain stopped. And needless to say, if you're a lab and you're trying to ask for 30 sensors and there's a manufacturer asking for 3 million, your order does not get any priority whatsoever. Okay. So that's another part that we're trying to push for, is trying to have some faith in that the local manufacturing community and the local scientific community can produce at these volumes, but we need the demand to switch to asking for local production so that then we can be able to justify. And when I think the question was asked to Elena in terms of scalability, all of this, you have to do local tests. No scientist can tell you yes until it's been built here, right? You can say we're pretty sure or we're highly confident, but until it's been built here, we cannot say yes. So that's another reason for asking. And yes, and I see, yes, great financial opportunity for those of you who are in the private sector and arrange for trade intermediaries or become intermediaries and market makers, creating markets for that link to develop these local scalable demand. I think that would be an excellent financial opportunity.
Agreed.
Any other questions before we switch? Okay, Cedrix, the floor is yours.
Hi, everyone. Hello.
Welcome. They're here. We have members here listening, and unfortunately the attendees are on mute, but they're hearing you. Yes.
Okay, great. I want to share my screen. Is it possible to take this? I hope you have a screen. my screen not open?
Yes, we can see your screen. It's
Okay,
not,
great.
we can see the PowerPoint. It's not maximized yet.
Mhm. Then I'll just go this way. Okay, switching from French to English. Let me try.
You can slip in a few French words here and there, don't worry.
Obviously, there will be French words there. My team prepared a presentation as if I was the only one to speak. I shall have up to 40 slides, but I'll go fast to keep on the time. From roots to roots. So, like Professor was saying at the beginning, we need to redefine our identity as Africans in the built environment. And I think it's not just for Africans, it's for everybody to go back to the roots. So with a past like this, how does and why does our future looks like this? Is it only the materials? Is it the technologies? Is it the approaches? Is it finance, lack of means, or in quotes, our inability to produce riches? Knowing that the focus of past building was about mimicking the nature and producing totally and completely reversible buildings, there's a wisdom that goes along the way. If you take, for instance, Einstein, he would say insanity is doing the same thing over and over and expecting a different result. So obviously, we are changing the narratives. I call this the sound of climate change because for years, for decades, we've been hearing things, but no more change is occurring. Instead, flood is increasing, civil wars creates loss of generations, desertification, etc., etc. So we must shift from sounds to concrete actions. And for me, what we call informal settlements are really what should be called formal settlement, because we have 70% of the population living there. So the little nice looking buildings all around are the informal ones because there are odd numbers around the massive ones. So how can we recreate a new pattern, a new Africa, new buildings, new market, obviously, by learning from the so-called informal and going from this point back to the early days. Some years ago, 2015, I think, I was sharing Christian Benima from Mass saying that we need 700 million more housing units, 300,000 schools, etc., to cope with the 2.5 billion inhabitants that we are supposed to have by 2015. Making my small maths, it means we must build 9 health centers every day, 33 schools every day for the whole of Africa, and 73,762 housing units per day to be sure that that population have a place and where to live decently. I'm not talking of those who can afford to have 7, 8 houses and etc., etc. So the challenge ahead is great, meaning that we just have to find a way to transform these challenges to opportunities, and that opportunity in a market. So every generation must, in a relative opacity, discover its mission, fulfill or betray it. We hope to fulfill it. I've been passionate a lot by space architecture. What can I learn from developed science or evolved science that is being prepared for Mars and more harsh environment that I can bring back to Earth, and knowing that when you are there, you are learning from scratch. Local 3.0 is the concept that I will approach here. So we have a local pattern, completely reversible, like I stated, integration, sustainability, all the aspects, be it culturally, material, and everything. Then you have the global pattern. The new material, despite our ability to make them more efficient, like cleaning concrete and etc. We'll state a paradox here I learned when I was trying to understand a little bit on economics, the Jevon paradox, that states that the more efficient we are in using finite resources, like coal or oil, the more resources we consume. So we must try instead to be focusing on circular efficiency. And now people are bringing out what they call, Lord Francis Kere calls it, a hybrid pattern. And we too, like in the Lonely House, Eco House here, we've been using that hybrid approach. But now it's time to shift to the rooted pattern. Rooted means that we don't just stick to what is considered as the sustainability scheme, but we instead add on it culture. And when you put together the two definitions of architecture, solidity, functionality, and aesthetic, you add on it AI, and then you come on this rooted pattern, you add on sustainability, culture, and you mix the two together, you come another nature sphere, I don't know, but another era of development where you can then now try to develop another approach to the house and everything. So I'll focus on a project here is the Mokolo by 2050. But we conceive it as if it was to be built in 2035. So it's quite possible to have it. And the idea is to scale all those goals in a city or in a small plot, but for this time it's a city. So that's why I was asking if they can produce sensors, because we'll have more details on various elements you're analyzing, the architecture, the climate, hydrography, maybe how do you say, fauna and flora. Flora is the trees, fauna, the animals and everything. So from Mokolo, we had to identify all those species, meaning the pluridisciplinary approach. What are the species? What are their various specificities? In which type of environment are living? What do they produce as ecosystem services or products useful for human? And what is the man doing that is disturbing their environment? We did the same thing with climate, and we also analyzed the architecture, obviously, the way the cities are organized. And we can see that various organizations are just repeating the Western world type of approaches, with particularly Barcelona, so-called plan seda. So sometimes you even see that in hilly areas where there are hills and everything and valleys, people just come and draw straight lines as if you just have to break down the mountain. And then to develop it become more expensive, because for a way to pass, you have to break down hills, and become more expensive. So we saw that the city has 3 areas, and we check on the various equipment in various zones to see what is needed. And our idea is to be able to rebuild in smaller land, the same capacity. So where are we taking exploration? I will talk less of fractal or mathematics today, but more of design. Here is the local pattern. We don't call it vernacular because that word, I hate that word, but it's the local pattern, it's rooted, it's what was there, was growing from their capacity to improve their technologies day after day. But also there's a transmission link, because when you want to, in operation and management of this type of architecture, means that there's generational knowledge transfer, because after each raining season, after 1 or 2 years, there's something that must be done on the building. And with that, the building was supposed to evolve progressively, so you have the various materials available. So we dig deep in analyzing shapes, how the wind goes all around it. But that's why I'm very happy for due to the prior expose, because talking of sensor means that you have much more data to improve on the quality of the architecture, and it's already a new market. Call it scientific market, but it will give more benefit to the finance later. So now we go to the plants level. And this, we have been doing it in various architecture. I understand that fractals in mathematics have the same logic, but when it comes to culture, you must analyze according to each and various architecture. It means the market becomes plural. The opportunity becomes located and can be scaled and shift all around. And those cross expertise will create more competition, so more benefits are possible to be made depending on your capacity of innovation. So here's the analysis of the problem in the city. So yes, and then we use that that floor plan, let's say it like that, of a small house, and we try to understand how do they live in that house and how can they live with the same pattern in the city. Is it possible? As you can see here, the 3 rounds represent the city now, and the 4th that is coming in is the extension of the city, but with much more capacity than the 3 on a smaller plot and a smaller land, taking into account all the challenges. And here is where enters only the holic design approach, where you can privilege the whole over, you don't privilege the whole over the parts. And even though the whole may be more significant, the parts are more fundamental and independent than the whole. So correction, restoration, everything is possible faster. We know that the area of Mokolo, because it's a northern city in Cameroon, the advantage of working in Cameroon is 4 different geographical areas in the same country. So you can study various type of, you have the forest, you have savannas, you have desertic plain, you have hilly places with stone everywhere. So, but here in Mokolo, there's too much flood from time to time. The seasons where the whole city is covered with water. So you can design for a whole neighborhood an elevated platform. And then on that elevated platform, you have ways, sleeping, cycling, everything on top of it. As you can see here, the various elements. And that elevated platform, in a certain sense, you can use it to integrate all the waste management patterns and everything. So you come with something like this. I cannot explain everything, it take too much time. How you come out with the size of the building, how is densing and balancing, and the material technology obviously is the same than the local one. The only thing that changes here can and should be the structure, because you must grow vertically, but without changing the way of living. You must create appropriate spaces for people to live in. I send links for videos. We can open it later, where you see how what they call the tree of life, taken back to the Egyptian kinetic strategies, to see how you compose the areas and everything. I think we should just play the video at the NYIC question, so I can explain 1 or 2 things there. And then also deconstruct the mentality. Here we are all scientists maybe, or designers, so we understand the difference between natural materials and concrete as it is being used now. And what are then the advantages? In conclusion, you will see that you shift from 8.48% of circulation to 10% circulation, but most of it being walkable spaces. And you know, in Africa, it's not easy to walk everywhere, because cities are always like highways. It's just a small corridor left there for people to cross, even not to walk on the streets. The green here is 1% in the old city, and you go to green to 37%. Surface bâti, meaning the space that is built, you shift from 50% of the land to 2.70%. 2.70%, yes. So you can imagine you're shifting from you gaining in land, so in the possibility to allow the nature to grow, to develop, or to increase farm space, let's say green farm space, and etc., because the same capacity is being put in just 2.70%. And it's not just due to high rising, it's also the amazing possibility that the local pattern gives you when you can understand it. And there was no water prior this. Now we have 1% of water area, and those 1% will collect all the flood waters and transfer it to develop new fishing ways and approaches that are now we'll just have to analyze the water, see if we can grow some plants inside that will ameliorate the environment, and which type of fish we can put there. And the recycling pattern can just be going on and on. And we know that we are in areas where there's not much water. So it's a great opportunity for at least seasonal period to have that water. So in terms of environment, you create a better environment for people to live. In Ping, there is the only road that is allowed for cars, because you imagine that you have cities or neighborhood like this, because it's not quite a whole city, but it holds the same population. I don't have the figure here, but I can have it once you'll be asking questions. It's the only place that is allowed for road. And we know that later, depending on technology, you can change it from, due to the size, you can change it from roads to highways, to tech ways, I don't know. So, and then once you have it, one building, you can build a digital twin at the same time and start monitoring from artificial intelligence to evolve the city, because essentially we have raw earth here. Then you will then analyze, and you have the ability to make your buildings evolve according to the new technologies available to your masteries of the various components of the materials. In a sense, it could be the bed of a never changing or evolving green agenda that will never stop, because there's no plateau. It's not like the Ponzi bill environment. And when we talk of Ponzi, you know, this Ponzi scheme where at a certain point there's no more reward and the whole financial house will collapse. Here, the investor can keep investing or gaining benefits. I will not say eternally, it will not live that long, but up to the level where maybe who say that the earth is too sustainable, I need it to reduce, to destroy a little bit. So idea, concept, design, manufacturing, operation, post, recycle, reuse, all this in the process when you wrote your approach in the various milieu. Obviously, you can learn from each local area to help evolve another one and get another market. So you have here the new city and let's say the old one. What is the difference? The number of inhabitants and also the fact that they are embracing new technology to manage their waste. And if you're smart enough to not be using plastic and stuff like that, we can have a more efficient circular economy, and then become more efficient in reuse eternally. So the materials we use are just, I'll not talk of data when my predecessor have very brightly talked about it and experienced it, but there's a data collection that is required, there's a data use, we must put sensors, make evolve the buildings. Yeah, I'm talking of the building without technology. If we automate, if we get it to become smart, and if we get the material to become smart too, imagine a biosource material that is smart. The capacities are much more greater than a smart concrete, for instance, because you destroy nothing to have it. And we are trying, we are still in trying process to be sure that, to make sure that we use only and completely reversible materials. For now, it's been difficult. What we do in the project, that's one of the project that is built, is to protect the walls as we can with the technique that's in French, they say bon boat, bon chapeau, meaning covering completely from rain, for instance. But here, we have the ability to grow it, the openings, everything. So I don't know if Cecilia can put us the video, if she has the link faster than me, because I think this was my last slide. Everybody smiles in the same language.
Okay, hold on. Let me try and transfer those videos. And while I'm getting the videos, Cedric's, one of the things that really excites me about Mokolo is this issue of dealing with flood. Because we have the fact that, like, here in Kenya, along the communities along Lake Victoria, with the coming of the El Nino rains, they're experiencing increasing flood. That lake borders, of course, multiple countries. But that problem is not just limited to Kenya. We've seen in Germany, cities, they're trying to create sponge concrete. In the Caribbean, during the hurricane season, the floods are increasing. The southern coast of the US, the same. And the solution in the West has been to change the permeability of the surface, but even with those, and China just went through, we're still seeing communities getting submerged by floods, even with increase in permeable substance as surfaces. So what you're saying is, let's start putting cities on elevated platforms. If you could explain that a little bit while I get these videos.
Okay. So after analyzing those solutions all around the world, as you said, nothing changes. You bring out solutions, but if you are still on the water level, water will increase and not stop increase. So there are two ways of going around it. Locally, when you analyze a project like what Kunle Adeyemi did in Nigeria, the elevated schools on the water, you understand that or you create floating surfaces or you build on top of the water level. And then you transform that water into an economic opportunity to sustain the elevated platform, or to reuse that money to build elevated platform. For instance, we must reinvent fishing, stop fishing in the seas in a certain ways. We must reinvent water use, water management. So flood gives them an opportunity. Yes, you must have more penetration on the ground, but you cannot have much than what the ground can take, for instance. So you must create areas to collect and stop a quantity of water to reinvent fishing. The money you have from fishing, you design it into elevated platform. And those elevated platforms are not just platforms, there are also waste center, treatment centers. So in a sense, you just have to look at the materials available. And for instance, if you don't have local wood that can stand water and stuff like that, then the auto-repairing concrete comes in place, because it will directly be in the water. So it will be then the opportunity to use those type of concretes and justify their use, because you have to elevate. You cannot live at that same level in those type of area.
That is actually a change in philosophy. Most of the industrialized philosophy is keep the water out. You're saying bring the water in, and once we
You
bring
must
that
bring the water in and transform it into economic opportunity, transform it into forest, humid forest, have inland mangroves because of the water is present. Mangroves are always around the borders of seas and things like that. So you can rebuild mangrove inside lands where around Lake Victoria, for instance, you build mangroves all around where there's drought. It creates a new ecosystem, and that ecosystem can help you effect what you are destroying elsewhere. You cannot fight water. There's no way you will fight water. The walls with falls, everything. So you must adapt. If you have to live in elevated platform, if you can live where water will not reach, you transform that water in economic or environmental opportunities.
And then the videos are loading. I think I've got too many things going here. Another question we get is that, or a challenge we get is that people say these ideas are theoretical, and they're looking for things that have been done already, sort of ready to go. Can you explain in terms of what your firm has done, the types of projects that you've already implemented and that clients are paying for, so that they know that there are people who do pay for this?
Yes, sadly, up to now, there are individuals, not yet community. If for the Mokolo project, for example, we have to discuss with about 37 local associations that want to see their city change. And it's together that we build that concept. But we only design what is buildable with the available technology. For instance, we have split, let's say, the offer or the way we approach it. There's eco-programmation, there's eco-conception, well, just put eco in front of everything. Programmation, conception, design, materials, and operation. Meaning that at all skills, for instance, we are finishing a house. The design is completely modern in what it looks, but all the materials are sourced on that site, for instance. The only thing that we brought out of the site was the concrete for the foundation. And it's a 2,000 meter square, not 2,000, no, 1,000 meter square land. But the way we approach it, you collect the earth directly, you put the mechanic equipment there and everything. So
you're getting a question from Dad in terms of bamboo. Have any of your projects involved the use of bamboo?
yes, we are increasingly using bamboo. We replace it, for instance, what they call alucobon. I don't know if the name is the same in English. Those aluminum plates that are used to cover high-rise building. Yes, we are changing it from that to bamboo. When we were looking at the PowerPoint, there's a point where I was showing is a building that we call how they call it again. It's near me. C'est encore par le bâtiment. Yes, masque de l'émergence. Where we are trying to use bamboo in facades while waiting for a proper technology here, because you must understand the local species, how they work and everything. But we are increasingly using bamboo to replace those metal panels on the wooden floors in various projects. But we believe that with bamboo we can achieve much more, and especially because, like you say, you touch the floor, it's a appropriate place to go and to grow bamboo, for instance. And we know that each 5 years you can come and collect everything, and you grow back again. So you have the potential for investor. You can just invest in producing bamboo. in a mangrove, knowing that each 5 years he have everything harvest, and 5 years later, and at the same time he's performing reconnection of, because things like snails, those little animals will grow there, and we have a new ecosystem.
So that's
So in
another
certain-
interesting point, because you're saying, instead of like right now, people say, okay, you have your forest somewhere remote and then you have the city. What you're saying is we could have the city, the forest in the below the city, and then you actually reduce the transportation time of going and harvesting the materials you need.
Yes, yes, you can just grow it around or in the city. There are wetlands in all African cities. Here in Yaoundé, for example, there are hills and there are valleys. The valleys are wet places. Now, much people use it to build informal housing and to perform informal activities. The city is now going to destroy everything. But if it is not replaced by another economic opportunity that helps those people have new jobs, and at the same time sustain the space, they won't be able to keep it for long before people go back to construct there. So you can grow bamboo. I saw a question first, but I did not have.
Yeah,
Okay.
about, do you have
Do you have local
factors?
manufacturing
Yeah.
processing bamboo? Up to now, we don't have. I don't say manufacturer; they're just technicians. So we have to use our initiative to create platforms where the guy will perform their know-how on specific duty for specific duty, but they have the ability to treat the bamboo appropriately, to grow it, and to have various products, because it's not only for construction. They produce furniture, they produce what they call charcoal, because once bamboo is burned, it seems it is a great for urban agriculture, because it helps increase production in small areas, small surfaces. So it just needs investment. But as an initiative, we cannot be preparing all documents for everybody at all sectors. But once we need it in a project, we have technicians and engineers that are able to use it. And it is not expensive. It's one of the cheapest, if not the cheapest material here. It's just that it's not being used into its full potential.
And I
It's
like
really,
what
it's
you
the
said
cheapest,
about
it's the cheapest one.
About
it's the only one
technicians.
even the state allowed to exploit without authorization, because it will grow back again.
You're talking about technicians, which brings another issue is the local labor. We also get a lot of challenges that the engineering and design capacity of, we have more quote unquote unskilled than we have highly skilled. But what you're bringing up is, if you design these projects right, you design them with materials that the communities already know how to work with. You're not introducing materials that are foreign to them, and you design them in a way that you're taking advantage of the skills they already have. You can then get a lot of expertise that's been locked out of the production cycle, because you're working with, like you're saying, what's rooted in the culture already.
Yes. Yes, that is absolutely right. Because they know how to use bamboo. The difference is that they will use it in maybe only one way. So it's up to you to say, okay, when you do your design, you produce the detailed drawings appropriately, and taking into account the way they assemble it, the way they generally manage it, or taking technology out of the bamboo, all of the way they're using bamboo, but in the way they are using wood. For instance, say the same thing you're doing with wood is possible to do it with bamboo. The only difference that for this size of wood, you must instead take this amount of bamboos because of the holes inside. The only thing that changes will be the section and things like that. And once they have done one or two, the next time they are the one introducing to you new ways or new strategies, because they are technicians, they are art workers, they are engineers. So at the end of the day, you create a possibility. One of the guys with whom we work have now created a massive initiative. He took, like, I think it's 10 hectares of land. It's small due to the need, but for somebody who just built one house to go to take 10 hectares of land to grow bamboo, treat them, and then start selling. When he will collect the bamboo, all the waste, they have a technique to burn it down to produce elements for agriculture. The ones that are remaining for construction are being used in construction. And here, for instance, all projects, private essentially, we don't use, is that they use to when they are pouring the concrete on slabs, is this bamboo that is being used to maintain the flat, I don't know, it's English that is disturbing, to maintain it balanced. Let's say it like that. So bamboo is really being used.
You had a slide where you had mud versus concrete in terms of local materials. And I just wanted to point out that in the US right now, there is a boom towards those who are looking, they call it earth architecture. Ghana's rammed earth technique is being mass produced in the US, but not here. So how do you deal with those who challenge and say mud is a substandard building material, yet it's being used abroad in high performance buildings but we're rejecting it locally? How would you address those challenges?
Like Professor Wandiga said in the beginning, those techniques have proven their worth already for centuries. So it's just people grew up watching Beverly Hills with nice white house. So once they want to build, they have that in their mind. So it's not easy to deconstruct what they have in their mind, because it's the subconscious that is speaking feelings and everything. So to challenge the feelings, you must bring facts. First of all, we have done an adobe modern house here. Now everybody sees it, they are completely seduced. So it's just the process of proving that it's possible. Like you say, Ghanaian ram earth, it's been widely used abroad, and the climate environment. Also, there's the finance aspect. When you have to work with somebody, if you prove to him that, okay, it will be cheaper in construction, cheaper in operation and maintenance, and the outlook, depending on his openness to new design or to casual shapes, the guy will just agree. Because when you, for instance, all of our project, the challenge is to save 1/3 of the budget. And that is possible almost each time. And despite the fact that the economy is not yet turned to green, it means that once we turn to green, and then you have the possibilities everywhere, the equipments everywhere, and everybody involved in the Jevon paradox will come in place, because the more efficient you are in doing something, the more efficient people are in consuming it. And that efficiency now is just repetition. He already have his prescale now. So if somebody wants to disturb you, who tell that there are 8 block schools in Gando, there he want a prescale. So it's the less actual things now. The only challenge is to route everything, to have it completely circular. For instance, you have to collect water to recreate fishing points. To collect water, you must have holes. And once you have holes, you have earth. And when you have earth, you have building material available. So meaning you wanted to recreate fishing to produce, because our seas are being destroyed, there are a lot of plastic inside. The time to clean it will take certain time. They can grow, say, algae, I don't know the name in English. Les algues, c'est quoi? Huh? Algae. Okay, it's the same thing. You can grow it to clean the water naturally while waiting for maybe advanced technology. You can collect the water in those holes. You take back the earth you use in construction. So you have a circular economy. And then you deep. Now, what am I doing with the earth? Well, the natural earth is what I'll use to, not natural, organic is what I'll use for my plants and everything in the city. The mineral is what I'll use for my, depending on the type of earth it is. If it's clay, to have your bricks. If it's laterite, like almost everywhere in Africa, you have various techniques. You have comb technique, and comb is a very nice technique for high rise because it's light. Then you had adobe, you have compressed earth blocks, etc., etc. So that earth can be even given to you freely if there's a connection of project, because the one challenging the fishing industry needs a hole. To have a hole, he must remove the earth. So once he have removed, what will he do with the earth? He will not put it aside. So it depends on how we approach it. And I'm just talking of big projects because, like I say, when we have a land, even in the middle of a city, we use only the earth from that land, meaning that there's no transport. The only thing that you rent or you have to buy is the equipment to produce maybe compressed blocks or the coffin when it's ram earth. Because people like Dr. Elena, they have labs. You give them the earth, they'll tell you the composition. And once you know the composition, and that is the cheapest thing to do, to analyze earth in a lab, to know the composition. Here is 75,000 CFA. If you divide it by 600, it's something ridiculous in euros. So it's the price of a bread. You just have to analyze. Once you have analyzed, you know which technology you use. You can decide to go rooted or to go smart, but whatever the case. And how do we have the earth? I'll analyze the sites. If I want to dig foundation, I will maybe change the position, the site, the techniques to have more earth if I need it. And that gives the opportunity to grow a bigger building and to have underground spaces that are very much needed to grow things like mushrooms and everything. So you create potentials. For instance, I'm trying to connect local associations that grow mushrooms and escargots and snails. Yes. We offer them underground space that users of the buildings we are designing don't want to use or are not yet ready to use, maybe for parking space and everything. They will come and grow those snails there. You have the amount of earth you want, you build, and at the end of the day, you have your 1/3 of reduction. And then the business can start all over again.
So there are a lot of important points that you're bringing up. Number one, on this issue of emissions, which is what everybody's trying to do with this climate finance. You're designing building, so this nature sphere, you're designing the construction process to eliminate as much as possible any transportation to and from the site of materials. You'll have a little bit of transport with the equipment. So all this energy in terms of extraction, you're now putting that on the site. Number two, you're developing absorptive capacity on the site because you're using the natural materials so that as the materials get extracted, any material that is not going to the construction, the structure itself, gets absorbed into local economic activity. So it's immediately put to use as alternative, be it farming, be it crafts, be it creating different types of on-site farming. The third part is that you're not designing single-use structures. And by that, I mean you design the office building and the only thing it can do is house maybe your computer people and your professional people and their parking spot. What you're saying is that building, whether you use it for office, whether you use it for residential, there are a myriad of activities beyond parking and beyond the actual formal office activities that can be going on simultaneously because of designing this with community, correct?
Yes, correct. And I can complete by saying generating single-use or segregated building is a method of the past. You have to stop it the fastest possible. So once again, it's the possible environment. If you have to develop a building that only hosts one type of activities, you will not generate maximum income and possibility, and then you have to be destroying nature from time to time again and again. So you must multiply the activities. The water reuse is an opportunity. The urban agriculture is an opportunity. There are some projects where you just have to change maybe the septic tank to a biodigester in a house, and then make associations with somebody that is doing élevage. I have my personal translator here. Yes, but people that are taking care of animals, let's say it like that, you bring the waste, increase in his waste, and you produce biogas. If you don't want the gas, another association can take it, and you have the compost and everything. So you must make all the projects circular, and the only way to convince maybe if somebody in his private house, unless he just wants privacy, is to show him that all those advantages are entering in his maintenance and operation, or even generating him income. Once he is satisfied, then there's no more problem with that. The only thing is that you manage it, meaning that if somebody finances such type of project, so the project is not just limiting in once you have produced the hospital, the house, or whatever, or the market. The project continues all along, all time, because there are many activities ongoing there for the maintenance and to generate other income than always beyond renting or selling the property, selling the various space and everything. So it's something close to that. So if somebody comes here, for instance, and install let's say a small industry for brick production, he will just have to bring the equipment, nothing else. The earth will be sourced on various sites and everything like that. So he will be able to connect with various individuals. Another ones also want to do urban agriculture. All the surroundings are available and open for that agriculture. Retrofitting the roofs or building houses with roofs that are appropriate, the underground, the underneath, the beneath. Even when you come to planish a land to have the floor that is proper for the construction, all that organic earth will go somewhere. The idea is, like you say, to redesign the process of building. And if you go back to rooted designs or architectures or buildings, you see that the community live in the middle of its economy. They don't go out of the place to take something else, unless they are in the area where there's no water and they need fish. But you can create small fish ponds because you need earth where it's drought. You can create, etc., etc. I think it's limitless. I'm just limited maybe because I'm an architect. At the end of the day, it's all around design.
So let's show people what you're talking about. And then, so there's going to be 2 videos. And then after that, hopefully start typing your questions in the chat and raising hands.
Feed yourself, Eden.
Is it showing?
Yes, we put flying cars for the beauty of the city, and believe we will feature transportation, so we can land from one place to the other, depending on the type of fuel we have them. To create a microclimate under various buildings. The network is disturbing from my end, but I hope you are watching it really well. Because the most of us.
City by design. Doing the things we do. Spreading the news we spread.
Yes, like we say, we save the world by design. Through design. Yeah, those translucent elements are to accelerate evapotranspiration, avoid water from the ground to evaporate completely. Understanding the connection between the various elements of architecture, drawing a fractal, scaling it up. So yeah, if I had finance, my first command would be so. I like architecture more than obviously, the platform must have holes, mimicking the forest. The forest are various layers. There are always open places where the sun can reach from up to down. Put the building in such a way that all the surfaces are able to have light all around. Tropical area is not that complicated, but you still need to do it.
Spread the news all around the world. Share the talks all around the world. We share design all around the world. Create the papers all around the world. We share the news all around the world. We share the purpose all around the world. We share the talks all around the world. We share design all around the world. Create the papers all around the world. We share the news all around the world. We share the purpose all around the world.
So I noticed you also used
this one.
cylindrical shapes instead of square or rectangular. I'm assuming
Yes,
that's
we are
deliberate.
the wind. Yes, it's deliberate. The wind there is very it's going fast. So once you analyze how the wind flows, and then you have to use that wind to cool the buildings and everything. So there are some openings that are weight. Yes, we can redesign it to be more squared, but we just left it as the simulation brought them out, so that air can be renewed all out in the buildings, and that wind can flow with no problem.
And you were
Watching.
mentioning, if you could highlight also, you were talking about, even though it's a forest, so it's a dense assembly of buildings, but you still have light going into everybody. We have a neighborhood here called Pipeline, where it's famous for the buildings are very close together and there's no light even reaching the ground. What you're saying is you can have high density and still have a community that's full of light, correct?
Yes, obviously we are in the part of Cameroon is the tropical forest, the Congo Basin. And when you analyze how some species grow and the amount of light they need, you understand that the forest needs to regenerate, to destroy itself in certain areas, to create what the clear air open where the sun can go directly. So you must analyze your density properly to make sure that nobody lives on shades during the whole year. So it's a must because light is life, and also it will help the soil and the ground regenerate, and some species that are like ants and everything can grow inside out. And then for humans, you must then now know which the quantity of light we need as humans, and then use it to create those holes where it's to be placed.
So now I'm going to do the second one.
Feed yourself, eat inside.
In this video, we're just showing how people can live in not conceptual. Here we are normally in the area where the forest, but due to the vertical inspiration, the density of the building, we are replacing the forest-like environment in terms of the way you manage the ecosystem. Able to bring this possibility everywhere. There are projects like greening the desert and benefit for such strategies.
How many people could live in the city at this time?
I'll check it and tell you the exact number.
Okay.
The document is also played. $100,000
Wow.
in a neighborhood, yes.
Sorry, it's yep, there we go.
And you see, even the inside, because it's not a design discussion, but even the inside, the way people are occupying the industry, it's not like usually. You are taking in account the way they are living now and just modernizing it.
I see you have
See the fish
drones.
ponds? Yes. The holes are to bring light down and up. The only thing that we could not put in those platforms were football fields. those will be converted in the ground floor because they were too big. Thankfully, people, as a group of producers that are doing a documentary on the project. So you have there the observation of the people of Mokolo, their requirements in the beginning, and then the observation of the project. Not just Mokolo, all the projects that we've been doing, those concepts, what have those are built. We're putting color on the floors because there are new technologies, electric technologies that can help yourself produce electricity. So for the outdoor light, for instance, can be useful. And if we do it in these cities now, we'll have to integrate things like fast vehicles, but since these cities, they are still used to bikes, cars, and things like that, we decided not to push the transportation innovation beyond what is needed. Like those water, the flood, and everything. Okay.
That's beautiful. So it opens the mind, like you're saying, to the different types of possibilities of what a city of 100,000 people, or a neighborhood. You were saying a neighborhood
It's
of
a neighborhood.
100,000.
We call it city, but it's a neighborhood.
Yeah. So after seeing that, I'm hoping there are questions. Questions, raise hands.
Yes, I see Elena asking, this is awesome. So in your opinion, what is the biggest challenges in achieving this vision? I think is being able to present it to the finance world the right way. Is the only challenge, because nothing is impossible there as from now to build, in fact. So that would be the biggest challenge, to break it down as I'm doing like this, but I'm not that good in breaking things down financially. To break it down to prove that, okay, from step one, this can give you money, this one gives you money, this how you invest in this how, then interconnect the whole to allow policies to grow from it. So to have markets open to that. Because in each various domain, you can create income. In programmation, city reprogrammation, meaning regulation, building codes and everything, you can use a project like this to recreate building codes to shift the markets toward working that way without you even being the main architect. To shift the market, saying that, okay, each time you use earth, you must create an opportunity for this. And then you start surveying the city to see where to do this and that. Each time you have a wetland, use it for maybe bamboo growing or recreating a mangrove that will absorb a certain quantity of water. So just in programmation, you can have in eco-construction at each scale. That's why we call it. We have not created the name Holonic, obviously, but that's the closest philosophical thinking that we saw that we can give while waiting to create not biomimetism but cultural mimetism, like we try to do. So at the level of materials, you can decide, okay, what is the potential of a location, what are the various materials. Here, for instance, the policy stating that for public buildings that says TBIT less than 3 floors, you must it's a must even build with earth. But up to now, people are still yet building with concrete and poor concrete, as a matter of fact, not even the high quality concrete. So you can shift the policy towards creating such an ecosystem. Then for those who want direct revenues, you choose a specific you can produce materials. You will be cheaper, obviously, so you sell more. You can produce housing, hospitals, and things like that. As the market is wide, you saw the statistic. We need more than 73,000 units of housing in Africa per day. As from next year, each day, to be sure that by 2050, everybody is living in a house. So there's how will you achieve it? You cannot be shipping materials to do that. That's not possible. It will take time. We'll waste the carbon in the process again. So maybe your house will be bioclimatic or whatever, but the economy will not be sustainable. If you want to have a sustainable economy, you just have to approach it in the rooted approach. And then to create space people are used to, you must take it from their informal or traditional way of living. Because if you go to the modern, you've lost 70% of your market.
And you have a question from Sebastian. We're at the end, so I want to make sure Sebastian has his chance.
Yeah.
Yes.
Sebastian.
Hello. Hi.
Yes.
I'm just first of all, really great presentation, amazing work. Thank you so much, sir, for presenting this. And I really love the local source and the local materials. And I'm just wondering, are there also considerations starting out with a hybrid approach of kind of using, carbon capturing methods to use, waste and plastic to put them into the building materials, kind of in a short-term basis? Obviously, long-term would be to use local sourced materials in the mud, but then also would it help the environment to capture the plastic and put them, like, for example, some places they make plastic bricks. Sometimes they capture carbon into cement. So would there be an opportunity for like a hybrid approach to that in at least the short term, to use that, especially if you need to scale and make housing faster, or would that be completely kind of going against it?
We cannot fight against people trying to reuse plastic. I'm just afraid that being more efficient in reusing will encourage more production of plastics, but we can use it in the manufacturer sector to construct basic shelters for industries. Because if you bring it in housing where you have the biggest needs in terms of materials, we will just create a desire to go towards it. And we cannot completely know the effect on health on those plastics in the long run, because house is a living organism. We have new illness linked to concrete and to some materials, like people are more fragile, their breathing systems and things like that. It's less performant than those living in complete earth buildings, because there's a exchange in terms of elements of nature and things like that. So I'll advise to go towards the manufacturing industries, or to, how do they call it? Maybe water collection systems. So not to use them in the building, because we have already the local material that are better for our health. Those plastic can be used there, knowing that the need is not that much, but it's much enough to remove the plastic from our environment.
Okay, thank you very much.
Yeah.
And you have a question from Charity Wairimu in the chat. What do you see as the trade-offs in adapting fractal architecture and planning compared to the more conventional Euclid, or what we're using now, which is the Euclidean approach?
As you saw there, I've shifted from a 73% use of land to 2.70%. to have the same amount of population due to the fractal use. It means that I have more free land for nature or for other activities. You have seen that I've taken 3 times less the surface area to achieve that, meaning that that neighborhood is 3 times less in terms of size than what is actually there. But it will host the same amount of population and even more because we can grow it more higher. I just stopped here because I wanted it to be buildable. You say want to build it tomorrow. Let's assume Elon Musk says that he can finance everything. Can build it tomorrow, yes. But if you go to steel technologies and printed technology, printing equipment and everything, you can go even higher. The only challenge will be to be sure that my forest approach of bringing light everywhere is taken in account. So that's the advantage of fractals, and that is at all scales, even in the furniture scale.
So repeating that statistic, you can use 1/3 less of land to accommodate 100,000 people. And
Let's say
have
1/3 to accommodate any population. If the local approach takes 10,000 people in a surface area, we'll just divide that surface area by 3 and you have the same population in that surface area, and without them living in a modern city nowadays where there's no real sense of neighborhood. That just high rise, and then the highways connecting them.
So for a developer, that is highly efficient because now,
Yes.
especially in urban area, you have the high cost of land. So you're reducing that cost of land acquisition by 33%. Do you have, in terms of square meters or acres, that concept design, how big of a space is needed? The one that we saw.
I've done I can just measure it and send it to you later because I don't have access now to my computer. I'll have checked all those figures. Too many projects, too many figures.
Yes, no problem.
To have in head. But it's obviously I just wrote 1/3. I just came with the. But even at the small housing scale is the same thing. So that project that we did on 1,000 meter square, we just use 200 to have the maximum amount of people that can live in the space. So it's the same thing we are doing. And sometimes it can be even lesser than 1/3 if the population is not that so much, not that much.
So then a takeaway from this first session is to think about people believe what they can touch and feel. Here in Kenya, they call it the knock test. So what we need to then do, you have a site in Cameroon. So we would need to see if we could find a site in Ghana and Kenya, and we could try to do this simultaneously or in sequence, and that would address the scalability, the transferability, all these questions that we're getting. That would be a pilot one, to have 3 of these Mokolos to come up.
Yes, that would be great. That would be great.
Okay.
That would be great. Having side from all these countries and Central Africa, Western Africa, in a sense, East or South Africa. Yes, it will represent at least a much more wide echantillon.
Yes. Any other questions? We're at the time.
If possible, with developers that are involved with the level of guarantee.
We'll have to get a developer who understands the concept, who won't try and shift the concept towards something that is faster to develop, quote unquote. We'll need a developer who wants to see this vision to fruition.
It only depends on when he wants it to be built. If it is with the actual technology, we can, there are various level of innovation. So all depends on the timeline, in fact.
Well, then we could potentially try, so if you're saying, so with existing technology, we could start immediately, and then let's say if we wanted to go all the way to push all the advanced technology, how does that change the timeline?
It's the planning timeline that we change, because like I say, if you take Mokolo, they can build it now. Like I said, there's nothing challenging. It's just the time to prove that each element is financially viable, yes, and brings revenues. Is the only time you will take, but there's a time to analyze the local architecture, the local everything, the local potential. So in a sense, you have to work maybe with Elena to send so much faster, because this takes too much time, because you have to read, to go back, to ask questions. Meanwhile, if you just found a living artifact, you put sensors there, in about 1 week, you can have various elements.
So using existing technology, we're talking of a timeline from in concept to finalized turning over for use. Is it 1 year or 12 months, 24 months? How long?
Let's say 2 years.
24
Because
months.
for what we have built, we have understood that we take much time in planning than in building.
Okay.
Because you must understand the local economy. Okay, what are they able to build, and how can I go towards that way? What types of shape are they using to put to assemble? Okay, I'll go that way. So now, how can I adapt my fractal to those shapes they are able to perform, to those materials they know how to use? Or how can I use the local material, but in the techniques they are used to? It's only that will take time. Once you have done that, you can even allow them on site. They will be able to understand everything, because it's what they are used to. That's when you go to the short-term approach.
Now that's actually for 100,000 people, 24 months is pretty much within the normal construction timeline. So we're not sacrificing time, delivery
No,
time.
not at all. Now
Great.
it's up to you to manage everything. CSTI, that's your job. I'm just
Yes, that's our job. Definitely, that's our job.
I can just be explaining you how I come out with solutions, because facing the problem or the questions that have been asked. Having communities like this, where you have much more questions, maybe you have the ability to save them by design.
Yes.
But because design is not just another scientific approach in thinking. So
Yes, we're creating a community, and what we'll definitely do is with this video, there'll be urban planners, there'll be public works officials, there'll be county zoning officials. So we will circulate this video and try to elicit more questions, to your point, to get more data into the design process.
And it would be great if you bring that data from the project you're talking about, those 3 areas. It can be even smaller projects than that neighborhood belt. Because once we are able to achieve them, no more questions will be asked. The next question will be, please, are you going along with us?
I like that.
Yes. So that's all. That's why I asked if they are developers, because if not, we might not end up building. That's the thing.
We'll find somebody. Don't worry. We'll find somebody. And with that, I'll let Dad give the closing remarks for today. And be sure to tune in to us tomorrow, same time, you have the links. We'll redistribute the links. And now I'll let Dad, Professor Wandiga,
Remain professional, please.
Yeah, thank you very much, everybody, for the wonderful time. I think we have learned from one another. We have exchanged ideas, and let's continue thinking about them and seeing how we can apply them. Have a good evening, or a good morning, or a good afternoon. Thank you.
All right. Goodbye.
Thank you very much. This is a really, really interesting discussions and very thought-provoking.
Thank you, Elena. Thank you, everyone.
Thank you. Bye.
Bye.
Bye.